Section 7, the final section that we'll cover in this chapter, basically is a continuation of Section 6, in which they showed us some basic functions. And here, they're going to make a slight change to those basic functions so that you can see how the graph will change. So, in our first example, our original graph was x squared. And then we're going to say, well, what does it look like when it's 2x squared? And so let's go ahead and plot in some points. Since there's no extra part, I know this is going to go through the origin. So at 0, it'll be 0. If I have a -1, -1 squared will give me 1. If I have a +1, 1 squared will give me 1. If I have a -2 squared will give me 4. +2 squared will give me 4. You can see the symmetry starting. If I have a -3, that's a 9. A +3, that's also a 9. So in a graph, start at 0, 0, 1, 1, 2, 4, 3, 9. And if we wanted to do 4, that would have given us 16. So that would have been up there. And then on the other side, -1 is 1, -2 is 4, -3 is 9, -4 is 16. So you can see how they go straight across. And of course, now I'm just going to connect the dots. And I have my parabola. Now I might mention, as a little bit of a shortcut, that once you know where the vertex is and you know it's going to have that left-right symmetry, you know without actually having to do all the calculations that you have to have that pairing off. All right, now let's look at f of x equals 2x squared. Okay, well again, we're going to start with the middle. The vertex is going to be at 0, 0. If x is -1, -1 squared is 1, times 2 is 2. -2, -2 squared is 4, 4 times 2 is 8. -3, -3 squared is 9, 9 times 2 is 18. And then, as I mentioned, the symmetry, I know that the positive ones are going to give me the same values. So when I graph these, this will have the same vertex down there, but then 1 is 2, so that'll be here, and then 2 is 8, so that's up here, and 3 is 18, so 3 is up there. And then I can go to the other side, -1, and the -2, and the -3. And so what you see is a similar looking graph, but it is narrower than the one I had originally. And the bottom line is, if the number I have in front of the x squared is greater than 1, it'll be a narrower parabola. If, however, the number in front of the x squared is less than 1, that will actually become a wider parabola. That would have been something out here if I had, say, 1/2 instead of the x squared. So this is the idea behind the last section here. How do things change when we add an extra little bit of complexity to our equation? All right, so now we're going to look at, instead of x squared that we had just a moment ago, we're going to say, well, what if we make it x minus 5 quantity squared? So we've added this little extra piece. What does that do? Okay, well, let's see. If I put in 5, 5 minus 5, of course, is 0. Squaring is not going to do anything. If I put in a 4, 4 minus 5 is -1, but -1 squared is just 1. If I put in, say, a 6, 6 minus 5 is +1, which gives me 1. If I put in a 7, 7 minus 5, that's 2. 2 squared, that's 4. If I put in a 3, notice how I'm going back and forth from the 5. 3 minus 5 is negative 2. Negative 2 squared again is 4. So you see how I'm pairing up my amounts. Well, when I graph that, the first point was here. And then I had 4, 1. So 4, 1. And then 6, 1. And then 7, 4. And 3, 4. And then if I had kept going, let's see, next I go over 1, but now I'm going to go up to 9. And then back 1, I'm going to go up to 9. And again, if I kept going, up to 16 now, and up here to 16. And so there's my graph. And hopefully what you see is the graph looks the same as it did before, it just got moved. And basically the rule is it's going to move in the opposite direction of the sign that you see inside the parentheses. So since this said negative 5, it moved 5 to the right. If I had had an x plus 5, then it would have moved 5 to the left. And so putting things inside parentheses moves it left or right. Now, for the second one, I have x squared minus 10. So let's just start off with our 0 again. 0 minus 10, well, that's going to be negative 10. What if I have a negative 1? Negative 1 squared is 1. 1 minus 10, that's negative 9. Negative 2. Negative 2 squared is 4. 4 minus 10 is negative 6. Negative 3, that's 9. 9 minus 10, that's negative 1. On the other side, 1 minus 10, again, negative 9. 4, 2 squared, 4 minus 10, negative 6. 3, 3 squared, 9. 9 minus 10, negative 1. So in graphing this one, I have 0, negative 10, which is down here. And then it's up 1 over 1. So those 2 points. And then over 2 and up here to negative 6 for the next one. And then it'd be to negative 1. So that's up here and here. And again, if I were to do this, the next one would have been up there, right here. And so now I have the same graph that I just did in red, but instead of being moved left to right, it got moved down. When I don't have parentheses, the rule is that's how much I'm moving up or down. So since this said negative 10, I moved down 10. If I'd had a plus 10, I would have moved up 10. So inside parentheses moves it left or right. Not inside the parentheses, not part of the squared term, it moves up and down. So all basically the same graph, but you can see how things get moved around. We call those translations. It got moved. All right, in 3, what we're going to look at is how do negative signs affect things. So first, inside the parentheses, so inside the square, we're going to do negative signs. So let's look at that first. Again, we're going to start in the middle, 0, 0. It doesn't matter if there's a negative sign. Now, if I put in a negative 1, well, negative 1 and then another negative sign makes it positive 1. Positive 1 squared is just 1. Negative 2, and another negative sign makes it positive 2. So 4. And of course, negative 3 would give me the 9. Likewise, 1, negative 1 squared, still positive 1. 2 becomes negative 2 inside the parentheses, squared becomes 4. And 3 becomes negative 3 squared, becomes 9. Note that these are the same numbers that I had up there. So putting a negative sign inside the squared term does not change my graph. It looks the same as it did before. By the way, you're like, how can you do it that fast? Well, that's because there's a pattern. If you look at the differences, from 0 to 1 is 1, from 1 to 4 is 3, from 4 to 9 is 5, from 9 to 16 is 7. In other words, I'm just going odd numbers. Up 1, up 3, up 5, up 7. This will always be true for quadratics. The difference between your y values will be the odd numbers as long as there's no number in front of what you're squaring. Now, in the second case, what if I put the negative sign outside of the parenthesis part? So it's not part of the square. All right, so 0 is still 0. Now, if I put in a -1, -1 squared is 1, but the negative sign out front makes it -1. If I put in a -2, -2 squared is +4, but the negative sign out front makes it -4, and -3 will end up as a -9. In the other direction, 1 squared is 1, negative sign makes it -1. 2 squared is 4, negative sign makes it -4. 3 squared is 9, negative sign out front makes it -9. And so it turns out that putting a negative sign out front basically does this. Just turns the whole thing upside down. And so this one goes this way. Now, I might mention that square terms are called even functions because when you put a negative number inside the squared term, it doesn't change the graph. It comes out the same way it does. But when you put the negative sign outside the squared term, it turns the whole thing upside down. All right, so what about if it's a cubic? In other words, the exponent part is odd. Now, as I mentioned earlier, we're only going to do 5 numbers anytime it's a cube, just because once you get to 3 cubed is 27. I'm already off the top of the graph, so I'm just going to do 0s, 1s, and 2s. So first I'm going to do the negative x case. So put in 0, of course that's just going to be 0. Put in -1. Negative of a negative is positive. Positive 1 times 1 times 1, 3 times. It's just 1. Put in a -2. -2 with another negative sign makes it +2. +2 cubed is 8. Now we're going to go ahead and do the positive one. So 1, -1, -1 cubed is -1. 3 negatives, a negative times negative times negative gives me a -1. Put in a 2, that becomes a -2. -2 cubed is -2 times -2 times -2, which gives me a -8. And so putting in those particular values, we're going to have 0, 0. -1 is 1. -2 is 8. +1 is -1. +2 is -8 down there. And so our graph goes basically like that. And of course, by the time we get to the next one over, it's going to be way up here, 27. So that's 20, 25, 27. It's going to be practically, with the 3, that's practically up there. And the negative 3 is off the bottom of the page. So that's why we only do the 5. And the middle 3 will generally end up in a straight line portion. All right, now what if we put the negative sign out front like we did in part 3? So again, I'm going to have 0, 0. If I put in a negative 1 cubed is negative 1. Another negative sign out front, so it makes it 1. If I put in a negative 2 cubed is negative 8. Another negative sign out front becomes positive 8. If I put in a 1 cubed is 1. Negative sign turns that into a negative 1. If I put in 2 cubed is 8. Negative sign out front makes it negative 8. And so this one will go in the other direction. And so so now if I put in the negative sign out front, I actually got back what I would have had with just a cubed function. In other words, if I had just replaced that, I would have gotten that same kind of, so I get it reversed here. So this would be an example of what we call an odd function. An odd function, putting in the sign, flips it. So note that when I put the negative sign inside the cube, it flipped everything. On the outside, it flipped it that way. And so that's pretty much it for the last section of this chapter. It's just to show you transformations when you start adding in extra pieces to your equations for the squared cases and the cubic cases in this case. And that wraps up chapter 2.